So now we're doing 8.1, Law of Sines and Cosines. These are used when you're dealing with triangles that are not right triangles. They don't have a 90-degree angle in them. So the Pythagorean theorem doesn't work. You'll see the law of cosines especially looks like the Pythagorean theorem with one extra term added on. Okay, so the law of sines says this: the ratio of the sine of an angle with its length of its opposite side is always the same, which can be written as sine A over capital A over little a equals sine capital B over little b equals sine capital C over little c, where the capital A, B, and C are angles of the triangle, and little a, b, and c are lengths of the sides, and the A is the side, little a is the side opposite angle capital A, little b is the side opposite angle capital B, and little c is the angle opposite capital C, angle capital C. Okay? Notice that this is actually three proportions. Proportion is a fraction equal to a fraction, right? Three proportions: sine A over A equals sine B over B, sine A over A equals sine C over C, and sine B over B equals sine C over C. You usually only use one of those at a time instead of all three. So we'll use when the problem involves two angles and two sides. So maybe one of the angles is unknown and another angle is known and the two opposite sides are known. Or maybe one of the sides is not known and the opposite angle and another angle and its opposite side are known. Right? That kind of thing. So the problem involves two angles and two sides. So the law of cosines is completely different. It looks like the Pythagorean theorem: c squared equals a squared plus b squared minus 2 times ab times cosine of the angle c. So notice the pattern here. The first part just looks like the Pythagorean theorem, right? The angle C is this isn't a hypotenuse anymore though. It's just some side of the triangle, and you take the cosine of the opposite angle from this side, which in a right triangle would have been the right angle, right? Cosine of 90 degrees is 0, or pi over 2 if you will. Notice it's the A and the B, the lengths of these sides, times the cosine of this capital C. So it's not A times C or something like that. It's the other two. So it's ABC with the cosine. And notice there's a minus here. That's important. And there's a 2. Okay? So you need to have that memorized. So just look at the patterns. Notice that when the angle C is pi over 2, cosine of C is 0, so this just becomes the Pythagorean theorem: c squared equals a squared plus b squared, because the third term becomes 0, on the right becomes 0. So this is a generalization of the Pythagorean theorem. So you usually use this when the problem involves one angle, which would be the angle C here, and three different sides: little a, little b, and little c.